So today we'll learn the Laplace transform of derivative. That means how to find out the derivative of, how to find out the Laplace transform of derivative. So let's see here. Now, the Laplace transform of derivatives, how to find. So let us consider you have a function f of t and which is continuous for all t greater than or equal to 0 and of exponential order b as t tends to infinity, that means e to the power bt, and if f dash t is a class of A, then the Laplace transform of derivative of f dash t exists when p is greater than b. That means the Laplace transform of your f dash t will be nothing but this one. That is equal to what? P into Laplace transform of f of t minus f of 0. And if Laplace transform of f of t, if it is p, then it will be what? P f of p minus capital F of 0. So capital F of 0 means what? In the given function f of t, just in place of t, just to put 0, you will get f of 0. So the formula is what? This is the Laplace transform of first order derivative. So f dash t. Dash represent derivative with respect to t. So Laplace transform of f dash t will be nothing but p into Laplace transform of f of t minus f of 0. So if you see this one proof, so Laplace transform of f dash t, use the definition of Laplace transform. That is what? From 0 to infinity, e to the power minus pt into f dash t dt. So then you integrate it using by parts. So if you integrate, taking this one f dash t as the first function and e to the power minus p as the second function. So if you by parts, if you do, so you'll get like this. Now if you put infinity first, that means when limit t tends to infinity, e to the power minus pt ft first. Then if you put 0, then what? E to the power 0 is what? 1 and f of 0. So minus f of 0 plus p, and this represent what? Nothing but Laplace transform of f of t. If you use by parts formula of integration, you will get this line. And from this line, I have written this one. Now, you have substituted infinity. So that I have not directly substituted. I have taken limit t tends to infinity, e to the power minus pt into f of t. Then what? Lower limit. So minus e to the power 0. If you put t equal to 0, so e to the power 0 is 1. And then f of 0. So minus f of 0 plus, and p is here p. And this is nothing but definition of what? Laplace transform of f of t. So this is Laplace transform. Now, as you know that if you take the limit as t tends to infinity over this, then its value will nothing but tends to where? Tends to 0. So the value, because the limit is t tends to infinity, so e to the power infinity minus infinity, that becomes 0. So that's why the value of this limit will be 0. So ultimately you are getting what? P into L of the Laplace transform of f of t minus f of 0. So P Laplace transform of f of t minus f of 0. So this is the first order Laplace transform of first order derivative. Similarly, you can find out the Laplace transform of second order derivative. So if I'll see what can we write? So let me write the general form. That means first we write the, okay, let me write first the second order derivative. So Laplace transform of your f double dash of t so this is equal to nothing but p square Laplace transform of f dash of t minus p Laplace transform of f of t plus f of 0 plus f of 0 means alternative plus minus will come plus f of 0. So now see, compare with this. Now if you see the general form, if I take the generalization form, so just a minute, just a minute. Okay, just I have done something wrong here. Okay, I have done something. Okay. I've done something wrong here. See here, it will be okay. P square L of f of t. Then it will be L f dash 0. Just a minute. Okay, just a minute. Here just to see. Here just to see. Laplace transform of f double dash t, f double dash of t. How to write? Okay, before that, let me write. First f dash t. Then it will be more clear to all of you. F dash t. So it is what? It is nothing but p into, just you have got that one, p into a Laplace transform of f of t minus f of 0. This is the Laplace transform of first order derivative. Similarly, if you want to find the Laplace transform of second order derivative, so Laplace transform of f double dash of t that is equal to nothing but, if you use this formula, so what you can write? First, P Laplace transform of, now see, it was here f dash t, so it becoming what? ft. So whenever you transform the Laplace when you transform it, so its derivative is decreases by what? 1. Here f dash first order derivative, so it becomes non-derivative terms, ft, f of t. So here it is second order, so it becomes what? It becomes f dash of t, f dash of t minus what? F dash of 0, because here also the next term f of 0, that means your derivative decreases by 1 and then put equal to 0, so it becomes what? F dash of 0, f dash of 0. Now here the Laplace transform of f dash t already you know, that is what? P into Laplace transform of f of t minus f of 0. So if you put here, so what? So P into what? P into this part. P into this part. That means P into this. P into P. P square. It will be what? P square. Laplace transform of what? F of t minus what? P into f of 0. P into f of 0 minus what? Minus this f dash 0. Minus f dash 0. Minus. So this is the Laplace transform of second order derivative. Similarly, you can find out the Laplace transform of third order, fourth order, fifth order, like this. So if you want to find out the Laplace transform of nth order, so if you see here Laplace, so what the chain you are getting from here? So see here, if it is first order derivative, then you are getting what? Whenever you transform, find out the Laplace transform of it, then its power decreases by what? So f dash t, so it is what? The power, first order derivative, so power of p is what? 1 here. So p Laplace transform of f of t minus f of 0. Now if you see the second order derivative, so it will be what? Second order derivative, so what? The power of p will be what? 2. So p square Laplace transform of f of t minus p f of 0 minus f dash 0. So similarly, if you want to find out the Laplace transform of third order, so it will be what? P cube Laplace transform of f of t minus what? P square Laplace transform of f of 0. P square f of 0 minus p f dash 0 minus f double dash 0. Like this you will get. So see here. So if you see your general form, so this is the general form. This is the general form of Laplace transform. Very simple. So see, nth order. So what? P to the power n. If nth order, then the power of p should be n. First, let's start with n, power of n. P to the power n, Laplace transform of f of t. After that, you won't get any Laplace transform. The next term will be what? After that, all minus sign will come. Minus, then power of p will decreases by what? 1. Then f of 0 minus. Now, from so first is what? Power of p start with n, whatever be the power, whatever be the order of the derivative. With that, the power of p will start. So p to the power n, Laplace transform of f of t minus, then power of p goes on decreases. Goes on decreasing by what? 1. So it will be what? P to the power n minus 1. And then it will be what? F of 0. Then what? Minus p to the power what? N minus 2. And then here, next step, the derivative of f goes on increasing by what? By 1. So it is non-derivative here. Then in the next term, it will be what? F dash 0. The next term will be what? P to the power n minus 3 f double dash 0. Then p to the power n minus 4 f triple dash 0. Like this it will go on. Ultimately, at last, when p is equal, when the power of p becomes 0, that means what? The n terms. So p n minus n. When it becomes n, then the power of p becomes 0. So at that point, the derivative of f should be what? See here, it is n minus 2, then it is what? 1. So you are getting 1 less. Because the power of p started from n and it goes up to here, it is n minus 2, then you are getting, it is what? First order derivative. So in that way, once the power of p, so it has decreases 2. The power of p decreases by 2. Then only you have got the first order derivative. So like this, if you go, the power of p goes on decreases by 1. And once the power of p becomes 0, that means nth term, then the power of, then the derivative, order of derivative of the last term will be what? 1 less. That means it approach in the nth term. So it will be what? F derivative, n minus 1 is derivative of f at 0. So this is the what? General nth order Laplace transform of nth order derivative. Okay. So from this, then there are some theorem you need to understand. First one is your initial value theorem. What is initial value theorem? So let us consider f of t is a continuous function for all t greater than 0. So continuous function, obviously you know. And suppose this function f of t is of exponential order as t tends to infinity. And if f dash t is a class of A, then limit t tends to 0 f of t is equal to nothing but limit p tends to infinity p into Laplace transform of what? F of t. This. Very simple. Just you need to remember this one. This is initial mean value theorem. If Laplace transform of limit t tends to 0, f of t is nothing but limit p tends to infinity p into Laplace transform of what? F of t. Similarly, for final mean value theorem, if limit t tends to infinity, so see here, in the initial mean value theorem, it will be t tends to 0 f of t. And then here, limit p tends to infinity p into a Laplace transform of f of t. But in the final mean value theorem, it will be opposite. So here, limit will be limit t tends to infinity. If limit t tends to infinity, f of t is equal to limit p tends to 0 p into Laplace transform of what? F of t. So this is your final mean value theorem. Our other conditions are same. Here are also continuous and it is of exponential order of t. So this is. Now see some problem. So here, if Laplace transform of f of t, it has been already given. If Laplace transform of some function f of t is equal to 1 by p into p plus beta, then find limit t tends to infinity. Now, one thing you need to understand, when limit t tends to infinity, then it is what? Final mean value theorem. And when limit t tends to 0 f of t, then it represents what? Initial mean value theorem, if you remember. So if it is what your limit t tends to 0, then it is initial mean value theorem, and if it is t tends to infinity, then it is final mean value theorem. Okay. So if you need to find here limit t tends to infinity f of t, that means you need to find what? You need to find limit p tends to 0 p into L of Laplace transform of what? F of t. And if you need to find limit t tends to 0 f of t, that means you need to find limit p tends to infinity p into Laplace transform of what? F of t. So that, and Laplace transform of f of t is already given, that is what? 1 by p into p plus beta. So that is. So here what? Laplace transform of t tends to infinity f of t. That means nothing but from final mean value theorem, limit p tends to 0 p into Laplace transform of f of t. So limit p tends to 0 p into Laplace transform of f of t. It has already given. That is how much? It has been given how much? 1 by p into p plus beta. So just to substitute here. Just simply substitute here. So this p and this 1 by p into p plus beta, 1 p will cancel, 1 by p plus beta, and if you put p equal to 0, if you take the limit, so it will get, you will get 1 by beta. Similarly, initial mean value theorem, that is same. Now, the next part is your Laplace transform of integrals. Like we have got the Laplace transform of derivative, similarly you will get the Laplace transform of integrals. So what is the first? If Laplace transform of some function f of t is equal to f of p, then it says that Laplace transform of integration 0 to t f of t dt is equal to what? 1 by p into f of p. This. So what is, if Laplace transform of f of p is your f of p, then Laplace transform of integration 0 to 1 f of t dt is equal to what? 1 by p f p. You can prove it by yourself also. So here g of t, let g of t is equal to what? I have considered this function as g of t. Another function I have given name it as g of t. So g of t equal to 0 to the power t f t dt. So if you differentiate both sides, so it will be g dash t, and differentiation and integration will cancel out, so you will get f of t. And obviously g of 0 equal to 0. This condition you have to substitute, put g of 0 equal to 0. Then if you take the Laplace transform on both sides, so Laplace transform of g dash t is equal to what? Laplace transform of f of t. That means Laplace transform of g dash t is equal to what? P into Laplace transform of g of t minus g of 0. And since g of 0 equal to 0, so that is what? P into Laplace transform of what? G of t. So therefore Laplace transform of g of t equal to what? This p bring to the what? So Laplace transform of g of t equal to 1 by p Laplace transform of what? G dash t. And Laplace transform of g dash t equal to what? Nothing but Laplace transform of what? F of t. So that is 1 by p Laplace transform of f of t, and Laplace transform of 1 by p Laplace transform of f of t is how much it is? Already given, that is f of p. 1 by p f of t. That is the proof. That is a simple one. Okay. So as a formula, you need to remember it. As a formula, you need to remember that. Now next is your next is your what? Multiplication by t to the power n. Multiplication by what? T to the power n. So if Laplace transform of f of t equal to f of p, then it says that Laplace transform of t to the power n f of t, that is equal to what? minus 1 to the power n, nth derivative with respect to p of what? Of f of p. Okay, so that n is a positive integer, that is n equal to 1, 2, 3, 4, 5, 6, whatever it may be. So that also you need to remember. So for an example, if you need to find the Laplace transform of say t square cos of, suppose cos of twice t, cos of twice t. So here you need to find the Laplace transform of what? T square into cos of twice t. So if you compare with this, so this is, if you consider this one as f of t, this one if you consider as f of t, then the Laplace transform of cos of twice t, already you know that. So you will get f of p from that. Then if you use this formula, so this is equal to what? Minus 1 to the power what? N means what here? N means here 2. N means what? 2. So minus 1 is whole square. Then differentiation with respect to what? With respect to p square. And that is your what? Second order. Of what? Of, that is what? Laplace transform of what? F of t. And Laplace transform of f of t means what here? And Laplace transform of f of t. F of t is what? Your cos twice t. So cos twice t is what? The Laplace transform of cos twice t by s by s square plus a square. A square means what? 2. 2 means 2 square means what? 4. So it will be what? Sorry. Not s. It is p. So it will be p by p square plus 4 over. So just differentiate it. Differentiate with respect to p twice, and that will give us the required result. So in this way, we'll be able to implement these all formulas. So the thing is that you need to find, you need to locate, you need to find out. Just very simple. If it is of the form t to the power n into ft, so this part t to the power n is this one, ft is this one. Just to find the Laplace transform of this and then use this formula, you will get the Laplace transform very easily. The thing is that. So as a formula, you need to remember this also. Now next is your division by t. Next part is your division by t. So here, if you know the Laplace transform of f of t is your f of p, then it says that Laplace transform of f of t by t. Then Laplace transform of what? F of t. F of t by t. F of t by t. What is the Laplace transform of this? So this is equal to integration p to infinity f of p dp, provided the integral exists. If the integral does not exist, then you won't be able to find out the Laplace transform. So if you know the Laplace transform of f of t is your f of p, then the Laplace transform of f of t by t is equal to what? Integration p to infinity fp dp. So that is equal to what? Integration p to infinity, not 0 to infinity this time. It is p to, it is p to infinity. It is p to infinity f of p. Already you have got what? Already we have got the Laplace transform of f of t as what? F of p, and dp, provided this integral exists. So for an example, if I would say for example, if I would say Laplace transform of sine of twice t divided by t. You need to find out the Laplace transform of this. So if you compare with this Laplace transform of ft by t, so f of t will be what here? F of t will be your sine of twice t, and the Laplace transform of sine of twice t, Laplace transform of sine of twice t will be how much it is? Anyone? What is the Laplace transform of sine of twice t? No one. 2 by p square
2 by p square plus 2
plus 4. Okay, so this will be, so you got the Laplace transform of this part. So if you use this result, so you can write what? Integration p to infinity and f of p. This is your what? This is your what? F of p. This is your what? Your f of p. This is your f. So it will be what? 2 by p square plus 4 dp. Now you know the integration. Just simply integrate it and put the limit. You will get the result. You will get the Laplace transform. Okay, so that's very simple. Just simple integration. Integrate it. Put the limit of integration. You will get the result. So see, a few examples are given here. Just already have explained that one. So here, Laplace transform of t into sine omega t. If Laplace says that if Laplace transform of t into sine omega t equal to twice omega p by p square omega square whole square, then it says that evaluate Laplace transform of omega t cos omega t plus sine omega t, and then you find Laplace transform of 2 cos omega t minus omega t sine omega t. That is simple. So f of t, just you consider this one as f of t. So that will be what? T into sine omega t. Then find out the first order derivative. If you find out the first order derivative of this, you will get the what? You will get this one. And if you get disconnected, so do one thing because it will get disconnected within a second. So please rejoin again, okay? I'm stopping here. Please rejoin. So this is your problem. That is your t sine omega t. So consider this one as f of t. That I have considered f of t equal to t sine omega t. Then you find the first order derivative. So first order derivative is this one. Now if you compare with the first problem, so what you need to find? You need to find the Laplace transform of omega t cos omega t plus sine omega t. So see, you have you got this one? The first order derivative is nothing but this one. That means you need to find out the Laplace transform of this one. Then if you find out the second order derivative of this, the second order derivative is your 2 cos omega t minus omega square t sine omega t you will get. So if you take omega common, from both the terms, so it will be omega into 2 cos omega t minus omega t sine omega t. So see the second one. 2 cos omega t minus omega t. That means here you need to, in the first problem, you need to find out the Laplace transform of what? First order derivative. You need to find the Laplace transform of first order derivative. And in the second problem, you need to find out the Laplace transform of what? Laplace transform of second order derivative. You need to find out this Laplace transform of what? Laplace transform of second order derivative. So very simple. So as you know, the Laplace transform of your first order derivative, that is what? P into f of p minus f of 0. P into f of p minus f of 0. So f of p is already given. So just because Laplace transform of f of p is what? This one. So this is your f of p. So f of p is your what? Twice omega p by p square plus omega square. So p into this f of p minus, now f of 0. So f of 0 means what? This is your f of t. This is your f of t. So in place of t, just you put 0. So 0 into sine 0 is what? 0. So ultimately f of 0 is what? 0. Okay. So if you put all this, so p into twice omega p by p square plus omega square whole square minus 0. So ultimately this is. So this is the Laplace transform of what? This part, first one. The second one, Laplace transform of f double dash t. So as you know that Laplace transform of f double dash t is your what? P square f of p minus p f0 minus f dash 0. Now f dash 0, you need to find. The f0 already you know. What is the f0? The value of f0 is 0. Now f dash 0 means what? This is your f dash t. So in place of t, just you put 0. So omega t, omega into 0, that is 0. And sine 0 is 0. So ultimately f dash 0 is also 0. And f0 is also 0. So just you substitute all these values. So p square into what? F of p. F of p means what? That is twice omega p by p square plus omega square whole square. Just to substitute. Minus p into f0. F0 is 0. That is f0 into 0. Minus f dash 0 is also 0. So this part, this whole part becomes 0. So what we will get? Twice p cube omega by p square plus omega square whole square. Now in the left side, one omega is common because directly we have taken this one. No? So one omega is common, and that omega if you bring to the right side, so with this omega, it will get cancelled out. With this omega, it will get cancelled out. So ultimately, you will get what? Twice p cube by p square plus omega square whole square. So this is the required Laplace transform of what? Of the second problem. So like this. Now if you see the second problem, so that is on the division form. Now what is it? If if of t is equal to e to the power at minus cos bt by t, then find the Laplace transform of f of t. So as you know that the Laplace, now if you consider this formula, Laplace transform of f of t by what? F of t by t, this formula. So what is the Laplace transform of this? Integration t to infinity f of t dt. So first this part, this f of t, you need to find the Laplace transform of this in order to use this result. So f of t means you need to consider this one is just to consider f of t here. So since capital F of t is already used, so give it name, another name, g of t, whatever it may be. So g of t by t. So what is the Laplace transform of above? E to the power at Laplace transform 1 by p minus a, and cos bt Laplace transform is what? P by p square plus b square. So then 1 by p minus a minus p by p square plus b square. So this is the Laplace transform of what? This numerator part. So consider this one as f of p. Consider this one as your f of p. And then you use what? Then you use the result. So Laplace transform of f of t by t, that is integration p to infinity fp dp. So fp is what? 1 by p minus a minus p by p square plus b square. So this is the integration. Just simply integrate this result and then you put the limit of integration from p to infinity. You will get the required Laplace transform of given function. That is simple. So just you need to put on the formula. This problem is very important. These all problems are very important. Now find the Laplace transform of sine of at by t. So that you can very easily can do. So consider f of t is your sine of at. Then find out the Laplace transform of sine of at. And then use the results ft by t. And that is p to infinity fp dp. That is. And does the Laplace transform of cos of at by t exist? Now, in order to use all this result, first of all, the function must exist. So now see here, as you know that whenever limit t tends to 0, sine of at by t, that is equal to what? A. How it comes A? How it comes A? That is your limit. If you remember, limit t tends to 0, limit t tends to 0, sine of, what is it is? At. And denominator is what? T. So it says that the limit t tends to 0, sine of at by t, that is equal to A. How it comes A? So if you remember the formula, limit t tends to 0, sine of t by t equal to how much? That is equal to 1. The sine of t by t, the sine of whatever it is, that should be in the denominator. But here it is sine of at, but denominator is what? Only t. So first you need to make it is at. So this A I have written extra. So I have divided by A. So what I will do? I will multiply it by what? A. I will multiply by. So ultimately this A and this A will cancel out. Again remain it is as it is. There is no change. Now as t tends to 0, then A into t tends to 0. So now if you compare, so this standard result, this the limit of this when at tends to 0, that will be equal to what? That will be equal to 1. So this limit will be 1. So 1 into A is what? A. So that is this. Then you need to find, then you need to check whether the Laplace transform of cos of at by t exists or not. So obviously the Laplace transform of cos of at by t does not exist because limit t tends to 0, cos of at by t is what? Is equal to 0, is discontinuous at t equal to 0. Okay. The limiting value will be infinity. At when t tends to 0, cos at by t, that will be infinity. So this function will be discontinuous. So for finding the Laplace transform, the function must be continuous for all t greater than 0. So first we have checked whether the Laplace transform of this exists or not. If exists, then we will find out the Laplace transform of it. So since it is you are getting a particular value that is A, so that means limit of what? Sin at by t exists, and so we can proceed for finding the Laplace transform of this function. So in order to find the Laplace transform of this, very simple, what we do? Just use the result of what? F of t by t. So f of t is what here? Sine of at. So f of t. So Laplace transform of sine of at is how much? It is a by p square plus what? A square. So a by p square plus a square dp integration what? P to infinity ft by t. Now just to integrate it, put the limit, you will get the result. But the Laplace transform of this cos of at by t does not exist because why? Limit t tends to 0, cos at by t does not exist. That means the given function is what? Discontinuous at t equal to 0. Similarly, this one, t square into e to the power minus 3t. So this is of which form? This is of the form t to the power what? T to the power n into what? Into f of t. This form. So first you need to find out the Laplace transform of this f of t, and then you need to use the result of what? Laplace transform of t to the power n into f of t. So first here f of t is your e to the power minus 3t. First you find the Laplace transform of e to the power minus 3t. Just consider give it name as f of t, and then use the t to the power n ft dt. So that will be what? P cube Laplace transform of f of t minus p square f of 0 minus p f dash 0 minus f double dash 0. And then you put all this value there, and then you solve, you will get the result. Similarly, this one is also of similar kind. Okay. So all problems are done here. You can check. It is t into sine square 3t. So consider this one as ft, but directly you can't find out the Laplace transform of sine square 3t because it is sine square. Okay. So here you can't find directly. So first t into sine square 3t. So what you need to do? First you need to find out the Laplace transform of sine square 3t. So sine square 3t you can't find directly. So convert it using the trigonometric formula as we have discussed in the last class, and then find out the Laplace transform of this, and then use the property of Laplace transform of t into f of t, t to the power n into f of t. And the other part is also that is your same kind. So here it is what your 1 minus cos t by t square. So that is very simple also, just what you need to do. So this 1 minus cos of t, you can use twice cos of t by t into 1 by t. Can you write? Can you write this one? This part. So t into t square or minus cos t by t square. So first you find out the Laplace transform of this part. Now and then here twice we need to use the property of what? Laplace transform of ft by t. Twice we need to use twice to get this whole 1 minus cos t by t square. So first we need to find out the Laplace transform of this part. First you find this one. So here consider this one 1 minus cos t as f of t. So that very simple, you can easily find out. So Laplace transform of 1 is what? 1 by p, and Laplace transform of cos t is what? P by p square plus 1 square, because coefficient of t is what? 1. And then use ft by t, integration p to infinity ft dp. So you will get the Laplace transform of 1 minus cos t by t. So then give it another name, say g of p, and then what? This one, consider this whole function consider as what? G of t. Consider it is what? G of t. So already the Laplace transform of g of t already you have got. Then Laplace transform of g of t by t again. Again use the result. Integration p to infinity g of p dp. Then integrate, put the limit, you will get the result. You will get your value of the Laplace transform for this function. So that it has been done here. You go through that, and integration part that you know obviously. So I'm not going about the integration part. Just simple integrations are there. Just to go through that. Then there are some more problems. Just to go through that one. If you want to understand, just to ask me, I will make clear. This is of same kind. Ft by t. This is also Ft by t. This is also Ft by t. This is also Ft by t. So in one problem, sometimes we need to use two, three properties, maybe more. Like in the here, e to the power minus t into sine of t into t. So first you need to. So here it is of the form Ft by t. So Ft is what here? E to the power minus t into sine t. But in order to find this one, what you need to do? First you find the Laplace transform of what? Sine of t. And then use the property what? E to the power minus at into ft. Just we have discussed. And then after getting the Laplace transform of this whole, then use ft by t properties. So there are many problems that you can do. So now see this problem. This problem it has been given some in another way. Your question is what? Evaluate 0 to infinity t cube e to the power minus t sine t dt. Okay. So what you do? Consider this t cube into sine t as your ft. So it is of t cube into sine t as your f of t. So t cube into sine of t. So the Laplace transform of this term, this part, you can find. How? First you find out the Laplace transform of sine of t and then use the result what? T to the power n ft. So from that we have got the Laplace transform of t cube sine t is how much? This one. This one. Now, since this t cube sine t you have considered as your f of t, you have considered it as what? Your f of t. So if you use the Laplace transform formula, so what is the Laplace transform of f of t? That is your 0 to what? 0 to infinity e to the power minus pt into what? E to the power minus pt into what? Into ft dt. This is your what? This is the Laplace transform of what? That is your f of t. This is your Laplace transform of what? F of t. So, see here. So t cube sine t. So t cube sine t. So e to the power minus pt into ft dt. So e to the power minus pt into ft. That is t cube sine t. And that is your what? This whole part is nothing but is equal to what? Laplace transform of what? F of t. Is it not? This whole part is nothing but what? Laplace transform of what? F of t. If you use the formula e to the power minus pt into ft dt. Now, the Laplace transform of this t cube sine t already you have got. That means Laplace transform of this already you have got. That is how much? Here. So Laplace transform of this already you have got. So, but you need to find what? T cube e to the power minus t sine t. So this part is there, but e to the power minus t, that means you need to put p equal to 1 to get this one. So if you put p equal to 1 here, then in the right side also you need to put p equal to 1. And see, so p equal to 1 if you put, so right side becomes 0. So the Laplace, so the value of this integration will be how much? Will be 0. Similarly here also same thing. So first you consider this part as your ft, this one, sin a square t by t. And then you find out the Laplace transform of first this one, and then use the same concept here as we have did. You will get the value of this integration. Okay. So there are many problems that you can do. Just to solve, find out, and you try it. If you want to understand, then just you ask me. I will explain it. Okay. So this is all about here till this.